I'm here with James Fodor. James has a YouTube channel, and he recently released a video where he criticizes the fine-tuning argument. And so, I'm a proponent of the fine-tuning argument. I think it's a pretty convincing argument. So we're going to be discussing kind of why we disagree about the success of the fine-tuning argument. James, for those who don't know who you are, who are you?
Oh, well, I'm currently a PhD student in cognitive neuroscience, I guess you could call it, at Melbourne University. I have a YouTube channel where I talk about philosophy and religious apologetics, or counter-apologetics most of the time. I also have a podcast, the Science of Everything podcast, so my interests are in the intersection of science and philosophy. And yeah, I'm particularly interested in arguments for the existence of God.
Yeah. I want to recommend the Science of Everything podcast. Just like if you're curious about, how something works, there's lots of, there are helpful explanations of just how various things work scientifically. Okay, so I guess I'll start by laying out just kind of the basic fine-tuning argument. So the way I see it, there are sort of two components to the fine-tuning argument. First, an a priori element that doesn't rely on any specific findings in contemporary physics, and then the findings from physics. So in terms of the a priori point, it's just that if you think conceptually, the vast majority of possible fundamental laws would not produce anything interesting, right? So you could imagine a very simple universe, just where there isn't anything that exists, or a very simple one where just all the particles move in a straight line, or where they all move in a circle, or there are an unimaginable number, there are an infinite number of these extremely simple laws that produce nothing of value. Well, in order to get laws that are able to produce any kind of life or any kind of interesting complexity, you need probably more than one law, and the number of the sets of laws that are not life permitting drastically outnumber the sets that are life permitting. So just as this basic conceptual point, it's very hard to get arrangements of stuff that produce anything interesting rather than just being sort of random static. And then the bit about from physics is, it turns out that we have evidence from contemporary physics that the laws, constants, and initial conditions, they're generally the most focused on the constants, but I think also the laws and the initial, well, I guess I'm less certain about the initial conditions, but certainly the laws and the constants are finely tuned in the sense that they are such that if you tweaked them slightly, then no life or complex structures of any sort could arise. So for example, if the cosmological constant was a little bit weaker, then everything would collapse in on itself. If it was a little bit stronger, all the stuff would fly apart. And it's in this very, very tiny range, about 1 part in 10 to the power of 120 of the available values. And so for that reason, we had the constants fall in an extremely narrow range that happens to be conducive to life. So the idea is that them falling in this narrow range that is conducive to life is extremely improbable, but it's a requirement for anything of value to arise. And so the probability of them being finely tuned is decently high on theism. Well, given how narrow of a range it is, it's very unlikely on atheism. And so the fact that we have constants in that range is very strong evidence for theism over atheism. So that's sort of the basic point. So yeah, James, why is the argument wrong?
Well, we should probably structure the discussion somewhat, because there's obviously different aspects to talk about. So we could talk about the conceptual point about the range of laws that are likely to be life permitting. We could talk about the scientific evidence for fine-tuning of the constants, which is where a lot of the discussion seems to be focused, even though I think it's interesting why that's the case, if we can why the need to appeal to any empirical evidence if a conceptual point will suffice. But then there's also the point about whether theism provides a satisfactory explanation for the fine-tuning observation, which is also something that I'm skeptical about. So where do you want to start in those issues?
Yeah, so I guess we can start with the conceptual fine-tuning point.
Okay, sure. So the argument here is that there is, of all of the possible sets of imaginable laws, is that the idea of the way things could be? Only a small subset of those would produce anything complex?
Yeah, well, it's not just like if you pick a random set of laws, right? For that it's unclear. But if you look at, there are going to be various ways of figuring out which laws are more likely, right? So there's going to be a weight towards simplicity. And so of the very simplest laws, virtually none of them produce anything interesting. The simplest way the universe could be is just nothing exists and there are no laws. And that would not produce anything interesting. Then moving up a layer of complexity would be there's stuff and it doesn't do anything. Infinite arrangements of stuff that you could have that do nothing. Very simple. We don't have that. And then moving up that is there's stuff that exists. It follows certain simple laws, but it doesn't produce anything interesting. So maybe you have just a bunch of particles and they all move in a circle. And that's just the entire history of the universe. Or they all move, they all move in a straight line unless they hit each other and bounce off. There are an infinite number of laws, or and you can vary the speed and so on and so forth. There are an infinite number of these very simple laws, and none of that. And maybe some of them produce anything interesting, but it's a very small share. And so the idea is it's very improbable that we happen to get one of the sets of laws that produces anything interesting.
Well, I'm pretty skeptical about these sorts of a priori arguments, but so one issue here is going to be that the number of complex laws is probably, if we can find a way to enumerate these, it's probably going to vastly outnumber the number of simple laws because of the extra degrees of freedom. So if we're going to sort of treat each one as equally probable, then it seems that complex laws are going to vastly outnumber simple ones, and we're not probably going to be able to say very much about what would happen in universes with the complex laws. But you're going to want to say, well, we should weight them by simplicity, which I think is what you were saying.
I think so. I think we probably should weight them by simplicity, but if you don't do that, then I think maybe the situation is even worse for atheism, because there are an infinite number of ways. So, I think if you think that the laws, given that, for every additional degree of freedom you add, you get way more possible universes, then you would expect the universe to be really, really, really complicated, right? So there to be, some huge number of laws, just if you assign equal credence across all the laws. But then if you expect really complicated laws, then you can't trust in induction, because the vast majority of very complicated laws will have different rules that apply at different times. And so it's similar to the problem for modal realism, where if you think modal realism is true, that every possible world concretely exists, then there are way more, well, maybe infinite in both cases, right? So maybe it's undefined, it gets a bit tricky. But it's either the probability is very low or is totally indeterminate that the sun will rise tomorrow, because there could be an extra law that will turn everything into a buffalo 1 second from now, for example.
So hang on, I'm trying to piece together the argument there. So the argument is that we don't live in the sort of universe that we would expect if the laws were very complex.
Right. Well, so
we don't find the universe we would expect if the laws were very complex,
right?
Because we can trust induction.
Yeah. It's that if there was actually, if it were the case that you should just have an equal your credence split across all the possible laws, because there are an infinite number of very complicated laws, you would expect very complicated laws. But the vast majority of cases where there are complicated laws would mean that that you can't give simple descriptions of the laws of physics, would mean that things are changing all the time and so on and so forth, because you have an infinite number of things describing what happens. And so if that's right, then it's very likely that you would get these simple descriptions of the laws, and it would mean that we can't trust induction.
Right. So how does that, and so what you're saying is that we can trust induction, therefore what's the inference we're making there?
Well, I think that this indicates two things. Number one, it indicates that we should have a bias towards simpler laws. And number two, it indicates that if you don't have a bias towards simpler laws, and you're an atheist, then I think you're just like you're just like probably in a skeptical scenario. And it's a very poor theory of our observations.
So the observation we're trying to explain here is no longer the existence of embodied life at this specific juncture of the conversation. It's the reliability of induction, and we're saying that in most universes with like different laws, you wouldn't be able to engage in induction reliably, but we can, and so that tells us something about what laws are more likely.
So the idea is that there are two different ways that you could, well, there are more than two ways, but two, simple generalization, right? There are two broad classes, two of the major ways of how you're going to assign priors across the laws are first having a bias in favor of simpler laws, and second, just not having any bias in favor of simpler laws and thinking that the laws are more complex. If you have a bias in favor of simple laws, then it's very improbable that we have laws that produce anything interesting. And if you don't, then it's very improbable both that we have simple generalizations that it can explain physical phenomena, where, for example, we don't see any, we have laws of physics that can describe what's going on rather than everything being chaotic, and we don't trust induction. So either way you do it, there's a problem for atheism.
So if we don't weight laws by simplicity, then we find that we can't explain why we find ourselves in a universe where we can make reliable predictions and inductions. Is that the idea? Okay.
Yes.
So I think where I differ is that I don't really see that in general there's much of a connection between the complexity of the laws and our ability to make generalizations or arrive at inductions. That there are, I think, a few major issues going on here. One is, obviously, we can make in our universe with our laws, we can make generalizations and engage in induction to an extent, right? It's like we sometimes can and we sometimes can't. And there's a question as to, well, what extent would we expect that we would be able to engage in prediction and induction and simplification of simple description of natural phenomena? And how does that, the extent of our, let's say, explainability of the universe, how does that relate to the underlying complexity, like whatever metric we're using to describe the complexity of the laws of nature? So I don't really see any particular reason there to be a close association of those. For example, because many of the generalizations that we use in, say, everyday life are statistical, rely on sort of statistical aggregates of huge quantities of matter, and the ways in which they behave, which if you describe them at a micro level is exceptionally complicated. Like I gave this example in my video, that we can't even really predict the properties of a helium atom, like with 2 electrons, without making that is, we can't predict it from fundamental physics without making a whole series of simplifications and using elaborate mathematical formalisms. So if you're just going to start with the laws of nature as we know them, obviously, like Lagrangian formalism of quantum field theory, and you try to, from that, to predict even the most basic properties of the helium atom, you're kind of stuck, right? It's extraordinarily difficult. So it's not at the point is the way that we make successful induction, almost always, I would argue, is not by looking at or by even using the equations that govern fundamental physics at all. It's by much higher level sort of statistical regularities. And I don't think that you can predict those a priori by just looking at the form of the fundamental equations. So I don't really see that there's any connection between the complexity of the fundamental equations and the ability to make successful predictions or inductions.
Okay, but if you have a world where there's no constraint on simplicity of the fundamental equations, then you wouldn't expect there to be and you wouldn't expect the fundamental equations to be predictable, right? So, we can measure, we can, and I'm going to butcher the physics, but, we can do experiments where we observe something about particle accelerators, where we observe the way that subatomic particles behave, and they behave in consistent and predictable ways. Maybe there's some chance at the quantum level, but they behave they don't follow just totally crazy random laws. And yet, if you think that almost certainly there are a huge number of laws that apply to these fundamental particles, then it's very unlikely that they'll be modelable by some very simple sequence of laws. In addition, the problem for induction is that if you're not sure what the laws are like at the fundamental level and you don't have a bias in favor of simplicity, then so here's a possible law that there could be. The law would say that up until 13.8 billion years in the universe, everything goes fine, and then 13.8 billion, and then after 13.8-ish billion years, just everything in the universe begins to follow a completely different set of laws. There becomes this new super strong force that pulls everything together and causes everything to collapse. I think it's very unlikely that there's such a law, because that law would add complexity, and it would also be sort of weird and arbitrary and less natural than other theories. But if you don't have any bias in favor of simplicity, then it's hard to see how you could be confident that there isn't a law like that.
Yeah, I think that's fair, because we do make assumptions about simplicity well, not assumptions. We make inferences about explanatory adequacy, which by appealing to the principles of the quality of an explanation, one of those is simplicity. So I agree with that. And that's why we typically would reject an explanation that an ad hoc explanation which just said, well, the laws change at a certain time. I mean, we have more fundamental principles of invariance, which lead us to think that there's sort of properties are conserved over time. But it's imaginable that there are universes that don't obey that. And so I think, I don't know, a related issue here is that I don't know that there really is a very clear ability to define the complexity of a set of laws. I suppose you could define it in terms of the number of independent constants needed to define those laws, but it does also feel like that the form of the equations matters as well. You could have a linear equation with many different variables, but alternatively, you could have a complex differential equation with the same number of variables, but sort of intuitively, the latter is more complicated. There'd be, I suppose, other ways of characterizing that. But I'm kind of suspicious about our language at this point as to what it's even meant by describing the complexity of the laws.
Yeah,
so what do you think about that?
Yeah, I agree that it is hard to know, to come up with a formula for figuring out how you calculate simplicity. And I know there are different proposals that have been floated. So, having to do with like Shannon and Kolmogorov, I think it's called.
Kolmogorov complexity, yeah.
Yeah, and I don't know the details of how those work, but maybe something in the vicinity of that is right. But I guess my basic view would be that that I don't know exactly how to calculate simplicity, but there are a lot of things where it's hard to get a very precise account of them. Like, it's very hard to get a very precise account of exactly under what conditions life arises. But nonetheless, we can know, sort of like a pile of sand is not alive and a person is alive, even if we don't have a precise definition. And so I think similarly, given how indispensable analysis of simplicity is, both for avoiding the conclusion that we're almost certainly in a skeptical scenario and any attempt to do science, we're going to have some measure of simplicity, which, it's going to be some measure of how many things are you invoking. But beyond that, if we want a precise formula, I don't know how to provide that. I don't know what that would look like, but I think, it'll be something in the vicinity, in the vicinity of that. So in other words, I'm not sure exactly how to figure out how complex a theory is in all cases, but I think, we can have this intuitive measure of how, if you add 10 extra laws for no reason, clearly your theory gets more complicated. If you, subtract, if your theory says a bunch of different things, okay, that'll add to complexity. There are cases where it gets complicated, but I think, we can have an intuitive measure. And if we don't, then I think we're in, Looney Tunes skeptical scenario where we're not able to do any kind of science.
Yeah, well, so as I've said, I don't think our ability to perform inductions is very closely related to the complexity of the laws, but also I think I disagree with your earlier characterization that the laws we have are fairly simple. So to take, for example, general relativity, Einstein's field equations consist of 10, 10 coupled nonlinear partial differential equations, which are unsolvable in the vast majority of cases, like analytically. So I wouldn't describe those as simple. Now, I suppose you could say, well, it could be 100 coupled equations, right? Well, there's further problems there because we don't actually know that we only know that the equations describe reality to a certain degree of precision. So we don't actually know if there's not additional sort of epicycles on that. So that's kind of one issue about the complexity thing, is that we don't know that reality isn't more complicated, but we're looking at an approximated simplification of it, which I would argue we almost certainly are, because all of our previous scientific successes, like Newtonian mechanics, for example, turned out to be approximations to a more complex underlying theory. But the greater point I want to make is we don't know very well how to define complexity. I would say that the laws of physics, as we do know them, so quantum field theory plus general relativity, are quite complex. For example, they're unsolvable analytically in anything but the very simplest scenarios. And so even if you just look at the set of laws that has sort of equal complexity class to the current set of laws that we have, again, we don't really know how to define that, but sort of conceptually, we're already looking at a very, very large set of possible laws. And within that range of possible different laws, I don't think that we have a very good idea about what proportion of those could give rise to life. Now, you point out that, well, very, very simple imaginable laws probably couldn't give rise to life if, for example, everything just sort of sat there and didn't do anything. Well, plausibly, that's true. But if we define the range of laws that we're going to look at by the complexity class defined by how complex the actual laws are, like as we know them, it seems to me that that already is sufficiently complex that we have very little idea about how common life is in that complexity set of, like, that complexity class of laws.
Okay, so I have a lot of disagreements. First of all, complexity isn't just, it isn't how difficult it is to figure something out. It may be that the laws of physics
Well,
are
what
very
is it
difficult.
then? This is the problem. It seems to be something different whenever you invoke it.
Well,
This is one of the problems I have with the notion in this context.
Yeah, so complexity is the number of fundamental entities that you invoke, and cashing out, okay, exactly what counts as a fundamental entity, and sort of like, what the relevant, some features of fundamental entities, that'll get tricky. But like if your theory postulates 5 extra things, clearly the theory gets more complicated.
I already don't agree here, because the laws of physics do partly postulate things, although I think you can dispute that depending on how you interpret them. But for example, you could say, well, actually, let's take general relativity. That's a good example. So one could argue that general relativity only postulates 2 things. It postulates the space-time, like the fabric of space-time, and then the matter-energy content of that space-time. Everything else describes the relationship between quantities of those fields. So I suppose you could say, well, they have multiple components, right? So maybe each of those counts as a different thing, although there's sort of set relationships between them. So laws describe relationships, not just things.
Well, I mean, whether laws describe relationships depends on certain controversial things relating to the philosophies of philosophy. But what, clearly...
But they describe how things behave. It's not just a thing. Like, a thing could behave in a simple way or a very complicated way. So you can't just say, well, my theory postulates one thing, and that therefore makes it simple. Well, I suppose theists do say this, right? But I just think that's nonsense, because it's about laws describe behaviors of things. And if the laws describe complex behaviors, even if it's, say, one thing, one field or particle or whatever, then it's more complicated. So I don't agree with this characterization that it's just the number of things postulated.
Okay, well, so, when I said things, I guess, construe that broadly to include laws, right? So the way that things behave. Yeah. Okay. So, and I mean, I like a decent, something that I think at least roughly tracks the complexity of a law is something like, if you wanted to give a simple description of all of reality, what the, of all of fundamental reality, what would be the simplest description that you could give? And, maybe there are going to be some exceptions to that, but that at least roughly tracks the laws. Okay. But I mean, my broad point is, look, simplicity, it's widely accepted to be a virtue in science. If we didn't accept
I haven't disagreed with that.
Okay, but if you...
My point is that if we take the...
It sounded like you were saying that you don't have a concept of what simplicity is supposed to be in this context. And if you don't have a concept of what simplicity is supposed to be...
Not a very clear one, no.
Okay, so then the way I'm using it, I don't intend to use it differently from the way that it's used in science, right? The point is,
but so it's not used in one way of science. That's part of the issue. It's a multifaceted concept, and when you apply it to laws of nature, I don't think we have a clear grasp on this. But I'm happy to move beyond this if that's not the crucial issue here. I just think it is relevant when it seems to be doing a lot of work in the analytical processing here. This notion of simplicity, and we can't really say much about what it means, but I do accept that there's some notion of simplicity.
Yeah, right. So clearly there's some notion of simplicity, and that notion of simplicity is informative, and it's going to inform what credence we should have in different theories. And if you doubt that, then you don't have any...
But I haven't doubted that, so we don't need to go through that. I just doubt we know how to apply it appropriately in the context of different laws of physics. Okay. And so I'm much more reticent to make these sorts of inferences about different laws. It's one thing to say we can assess the simplicity of... different explanations of a specific biological or physical phenomena in the context of the laws of physics that we know, or modifications of those. And another to say, well, considering the class of different imaginable physical theories, let's assign a simplicity measure to them. Those are very different things.
Well, but we are going to, in order to trust induction, we are going to have some assumption that simpler ultimate laws of physics are more likely, right? Because you're going to have to rule out the low probability, all the infinite number of, crazy forces that there could be that only will start taking effect 1 second from now that would cause everything to collapse or to fly apart or do any of an infinite number of things.
I don't know that we need the global measure to do that. All I need to be able to say is compare these two theories. One that introduces an ad hoc force at one moment and the other that doesn't. And I can say, yeah, I can pick the simpler one of these. That's very different from saying, the issue here is if you're going to say that the vast majority of possible sets of laws are not life permitting, you need a global picture of a way to assign globally across a huge range of different possible theories what the simplicity or complexity of that is. Whereas in order to make these sorts of assessments that you're talking about, you don't actually need that. You just need to be able to compare across specific alternative hypotheses, essentially. And I think that we can do that much more easily than we can provide a global measure. And in fact, it's even mathematically possible that you can compare sort of locally a series of different theories and assess the complexity without there being a global measure. So that introduces further assumptions about like the structure.
So my point is just that if we have no bias at all in favor of simplicity, then we can't trust induction in favor of simpler theories of ultimate reality.
Well, I've just disagreed with that. But again, I don't even know that that's essential here.
Yeah, maybe I'm not understanding, because it sounds, and I assume I'm misunderstanding, but it sounds like you're jumping between saying, I'm not disagreeing that simplicity is a virtue, but I'm just saying it's hard to figure out how to calculate simplicity. And then when I say, okay,
in this context, yes, absolutely.
Wait, okay, so you just to be clear, you don't deny that simplicity is a virtue?
No, I don't.
Okay, do you deny that do you think simplicity is a virtue in terms of the fundamental laws? So fundamental laws that have fewer components are to be preferred? Even if we're not sure exactly how to calculate simplicity, just whatever the right theory is of how to calculate it, things that are simpler, there will be a bias in favor of them.
Well, I'm less keen to agree to the way you've described it there. I think if we're choosing between two theories that are equally predictive or explanatory, then we should prefer the simpler one. That it doesn't follow from that we can provide a global measure of simplicity across the full range of theories. That's a further assumption that I'm quite skeptical about.
Okay, so you don't think. Wait, okay, so your point is that you're not sure if we can provide a global measure of the simplicity of all the theories, but
I don't know that there is one.
Okay, right. You don't know if
mathematically. So I can say A is greater than B. It doesn't follow that for every number I can put them in. I can provide a cardinal measure of their every number, right? Like that just doesn't follow. That's a further assumption.
Yeah. Would you object to the following statement? Had there been nothing at all, that would be simpler than whatever our current laws are.
See, that's certainly very intuitive. I'm kind of skeptical about that because I feel like our concepts are just not really suited for those sorts of inferences. But if you press me, I'd say, okay, yeah, let's grant that. But this only gets us so far, right? Because this is what I was talking about complexity classes, that we should look at the complexity class of the level of complexity of our current laws and think about, well, what are all the sets of laws that have that or less complexity, and ask what proportion of those would be conducive to life. So this is why I was saying I don't know that it's crucial to focus on whether I think we can define complexity. I think it matters, but I'm happy to grant that for the sake of argument and just make the point that our laws are already sufficiently complex such that I don't think we can say much of anything about what proportion of laws that are at least that complex would have life in them.
Oh, well, my point is that it's very improbable that we would get laws. So I don't know if our laws are that complex, and I think part of this will come down to whether you think there are like different particles that we currently take as fundamental. Maybe we'll find some deeper explanation of. So I don't know exactly how complex our laws are, but even if you think that our current laws are pretty complex, it seems that if you think they are complex, then it's improbable that we would get laws as complex as our own laws if you have a major bias in favor of simplicity, rather than one of the infinitely many laws where there's just stuff that doesn't do anything, or the infinite number of just extremely simple patterns of things moving in a circle or moving in a straight line, or like just moving 1 inch and then stopping, and so on and so forth.
Yes. But how does that get us to a fine-tuning argument?
Well, the idea is that if naturalism is
for
true,
laws, focusing on the laws.
Yeah. So if naturalism is true, it's very unlikely that we would get one of the laws that produces anything interesting or valuable, given that it's very improbable that the laws would have the requisite level of complexity. And even if they do have the requisite level of complexity, that they would happen to be one of them that produces anything interesting or valuable.
Okay, so your argument, I'm still not sure I'm understanding the argument here. The claim is that we should assign higher probability to simpler laws, but there's also an observation or a recognition of the fact that there are more complex laws than simple ones, more possible complex laws than simple ones. So how do we know that? Like, let's imagine there's 3 levels of complexity in laws. There's 1, 2, and 3, right? And we're going to say we're going to weight 1 higher than 2 and 2 higher than 3 in terms of their probability, right? Because of the greater simplicity. But there's also a larger number of members of the sets, 3 compared to 2 compared to 1. So what we should do to work out how likely it is that we would observe a law, that we would be a law in a particular, like we would have laws in a particular complexity set, is to take the probability of observing like a simplicity weighted probability of getting a member of each class, 1, 2, or 3, and then multiply that by the number of sets of laws in each class, right? And then that gives us a measure of the probability of each of those spaces. And you're saying that you know what the answer to that is, and it's that we should have a less complicated, that we would expect to see a less complicated set of laws than we actually do.
Yeah, my thought was that you don't just need some bias in favor of simpler theories, right? Suppose you have a very, very slight bias in favor of simpler theories, where you say all else equal, a simpler theory gets twice as much probability mass as a theory that is, a lot more complex. Well, then, because there are so many more complex theories, then you'll get a huge bias. You'll think that almost certainly there.
Well, this is my point, right?
Very complex laws, right? But so my point is that you need a very strong bias in favor of simpler theories, enough that you think that even the infinite number of more complicated laws are dwarfed in probability by the simple laws. Because if not, then you assume that the laws are infinitely complex. Not necessarily infinitely complex, but you assume the laws are very, very complex. And then given that there are an infinite number of complex laws that would undermine induction in some way, then you should not trust induction, and you should not expect there to be simple generalizations of the laws.
So my argument is, okay, so what is this an example of a simple generalization? Because it seems that now we're not actually, this is part of my issue, that we're jumping between different topics. One is whether we would expect to see life with a given set of laws, and another is whether we would expect there to be simple generalizable inductions, and those aren't the same. Those aren't the same argument, and so I want to appeal to different considerations when addressing one. So here we're now talking about whether there are simple generalizations of a given set of laws. So what's an example of what you mean by this? Because my argument before was that I don't know that there's much connection between the existence of simple generalizations and the actual underlying complexity of the laws. But maybe you mean it differently. So you mean like...
Well, like, for example, we can calculate the strength of gravity between any two things using the inverse square law, right? We don't observe that that it's just constantly knocked afield by random forces, such that the degree of pull between two objects just randomly happens to be 1,000,000 times higher or 1,000,000 times weaker than we would expect it to be, or some other force moving in some direction. And so if there were very
yeah,
like
I was just thinking of what you're saying.
Yeah, if there were just a bunch of other laws that were constantly affecting things, we would expect that to show up in our physics. We would expect, the particle accelerators not to be able to reliably predict how things will behave, for example. And apologies.
Yeah, well, so this is my problem, right? So things are predictable until they're not, right? So there is a level of predictability, let's say at the level of particle accelerators, but there's many things we can't predict. Like a renormalization problem in quantum field theory is a good example of this, because there are many calculations we simply can't do, things we cannot predict. There are some things that we have, I think, through Herculean efforts of mathematics being able to predict. And I don't regard those predictions as sort of as simple or straightforward to do. If you've ever tried to do even a tree level computation, the simplest type of calculation in quantum field theory, you'll know what I mean there. They're extremely grueling. I don't really call that as simple. And that only describes the very most basic type of interaction we observe.
There's a difference between how hard it is to describe the ultimate goings-on of the system and to calculate the higher order phenomena of the system, right? So you can have very simple things, but then the interactions that they produce end up being very complicated and hard to model. Complicated in the sense,
but that's what laws describe, the interactions. We just agreed to that before. Laws don't just describe things that sit around; they describe the interactions and processes that exist between things. And so, if those are
Yes,
complicated, then that's the laws are complicated.
well,
And that's my point. There are
no,
some cases
so
where we can make reliable
okay.
predictions, but there are vastly many where we cannot. And so, what range?
So
It seems that the mere
they're
existence of
both
the ability to
fundamental.
make predictions in some cases is being treated as if that's improbable. But that's what we would expect, is
No,
that any set of laws would have some situations in which
so
it's possible to predict given certain information and some in which it's not. And we'd
so
have sort of some measure of predictability, I guess, across different situations. And you're telling me that the amount of predictability, that, like simplicity, there's predictability and simplicity in the universe, I guess, right? You're telling me that the amount of predictability that we observe in our universe is much higher than we would expect by sampling random universes of our level of complexity. Would that be an accurate statement?
No, my point is that it's very unlikely that we would get laws at our level of complexity, because for every additional level of complexity that you add, then there are way more laws like that. So for any particular level of
But now you're jumping back to the other claim, right? Because I talked about that, but then you started talking about predictability, because simplicity and predictability are different things. Okay, so you said, yes, but the problem with complex laws is that they won't be predictable anymore. And so I'm saying, okay,
I'm not jumping around. What I've done is I've given two arguments in favor of the bias for simplicity. One of them is that if there were not a bias in favor of simplicity, then you would expect there to be lots of very complicated laws that are constantly interfering with everything, and then you would not expect everything to be predictable. Now, in terms of what you just said, you pointed out that the laws govern the relationships between things. But there's a difference between the fundamental laws and the non-fundamental laws. So the fundamental laws are the most basic descriptions that don't reduce to any deeper things, and the non-fundamental laws do reduce to just the most basic. They are fully explained by the most basic things. My point is that if you don't have any bias in favor of more basic fundamental laws, then you would expect extremely complicated fundamental laws, and so then you would expect everything to constantly be interfered with by by all these new fundamental laws, and you would not expect there to be simple descriptions of the goings-on of physical phenomena.
Okay, and the argument is that we do have simple descriptions of fundamental physical phenomena.
Well,
in our universe,
we have at least descriptions that are way more accurate than you would expect the descriptions to be if there were, potentially, millions of random laws affecting things in huge ways.
So this is what I was saying by predictability. So we can talk about predictability as if it's our ability to make simple descriptions of the behavior of fundamental physical systems, right? This isn't supposed to be a gotcha. I'm just trying to introduce a word so that I don't have to say predictability of fundamental systems every time.
Yeah, can you just repeat what the definition of predictability was?
So predictability is supposed to be a measure analogous to simplicity. So it's not binary, right? It describes the extent of our ability to make generalizations or simple descriptions of the behavior of fundamental physical systems in a given, with a given set of laws. So different laws will have a different kind of level of predictability, just like they have a different level of simplicity.
Yeah, right. So then the point is that if there's no bias in favor of simpler laws, then you wouldn't expect there to be the level of predictability that we observe.
Right. And so your argument is that we observe a predictability that should motivate us to have a bias in favor of simplicity of laws. The amount of predictability we observe. Right. So my concern about that is I don't think we have a clue as to what level of predictability would be expected with given levels of simplicity. So you're saying there's an association between simplicity and predictability, that when we see a certain amount of predictability, we should assess, we need at least this much simplicity, because otherwise we can't explain why we'd have that much predictability, right? And I'm saying I don't think we know that at all.
Right. So it's obvious, if we observe some level of predictability, like the fact, we drop things and we observe predictably that they fall.
Yeah.
Right. I agree. We can't be confident in precise judgments of, okay, there are between 3 and 27 fundamental laws, no more, no less. But, we can be confident that there aren't just 100 quadrillion random different fundamental laws that vary in tons of ways, because if there would, then you wouldn't expect there to be this degree of predictability. You would expect one of the laws to, make it veer off course under certain conditions. Another law to, when things are in particular locations, do other things that interfere with its behavior. And for their
maybe it sort of depends on the on what those laws are. Now, 100 quadrillion is a very large number, but the thing is,
but if you have if every time you add, you add an extra law, you get like potentially infinity extra degrees of freedom, then I mean, the math does get tricky, but you either get certainty that if the level of complexity of laws, the number of free parameters is either n or n plus 1. You either get totally undefined credences in the laws having simplicity being the simpler one, or you get certainty in the complex laws. And if that's right, then you should think the laws are infinitely complex. And if there are an infinite number of laws, then you wouldn't expect there to be.
I didn't quite follow that argument. So if we have infinities in our physical system, which we often do if we're talking about like degrees of freedom, because the number of degrees of freedom may not be, well, it depends what you think about quantization, I suppose, but that could potentially be infinite. Then you just need a normalization procedure so that it can give you finite numbers out of an infinite range, which, I mean, we can do that, but I think we're getting off topic a bit here. I sort of uncomfortable talking about infinities for this reason, that it gets difficult, but we can just talk about very large, and that probably suffice. Yeah. So there may be some cases, I'm not denying that there may be some cases at either extreme where we could make some inferences about the amount of simplicity versus the amount of predictability. I mean, at an extreme example, you could say, well, what about a universe that had absolutely nothing happen and that's it, right? Well, that's sort of maximally predictable, right? You know what that's going to happen. Okay, granted, right? And you could, in another extreme, specify an exceptionally like googolplex number of laws, which sort of describe particles randomly moving to any arbitrary location in the universe. Okay, at some level, that's not going to be predictable. I agree there, okay? So there are extremes that we can say, yeah, this much simplicity, that's going to be predictable. This much complexity, that's not going to be predictable. My argument, my disagreement, I think, is that the fact that we can identify extremes like that, and, we could debate about exactly what cases we can predict. The fact that you can identify extremes doesn't mean that we have enough understanding about how to deploy these concepts, predictability and simplicity, for the fine-tuning argument to go ahead. To say that, well, what we can say is that we need to have enough, because your point is that we need to have a pretty strong bias in favor of simplicity in order to explain the amount of predictability we observe in our universe. And my argument is, I don't think we know that, because we don't have enough knowledge about the relationship. Yes, certain extremes, you could say, but this is not nearly sufficient. When I think we need to have a lot more humility when we're talking about different laws of physics. I point out many times that it's very difficult for us to even know what is possible without laws of physics. This is why I give the example of the helium atom, which is something that's simple, but yet so complicated to describe. Like, it's very difficult for us to even know what properties are consistent if you're just working from the level of fundamental physical equations. And we're not even just talking about that. We're talking about other possible sets of physical equations, which could be very different to our own. I think we need way, way more humility in making any very strong inferences about what the relationship between predictability and simplicity is. And so I'm just not willing to grant these sorts of generalizations that you are.
Okay, well, I think that you do need a very strong bias in favor of simplicity, so that you don't end up thinking that it's infinitely more likely that one of the infinite induction destroying laws is actual, right? Because there are an infinite number of laws.
I just said I'm uncomfortable talking about infinity. Do we have to talk about infinity, or can we make it very large, or is the infinite nature important?
Well, okay, right. So there are at least Graham's number ways in which there could be laws that undermine induction, right? You could have there could be a law that is dormant until 1 second from now, and then makes everything in the universe turn into one particle, or two particles, or three particles, up to Graham's number particles. And so in order to think that the law is continuing chugging along as they've been up until this point, then you have to think that almost certainly none of those Graham's number laws are actual. And if that's right, then you need a very strong bias in favor of simplicity, where to cancel out all the extra gerrymandered laws that you could add. So that's why I think you need a strong bias in favor of simplicity.
Yes, I think that there's certainly something to that. I still don't know that that gets you to the inference you want to make, though, because I was saying before, let's just completely let's ignore everything that's more complicated than our current set of laws, and just look at everything that's equally complex or less complex. This is what I was trying to say earlier to kind of, because I don't know that it's that helpful to talk about these sort of highly contrived examples. If you just constrain ourselves to that range, I still don't think that we can say very much about what the relationship is between complexity and predictability for the inference to go ahead.
Well, I think maybe we can say stuff about that range. That it does get a bit trickier. But the point of the argument is that the level of simplicity that you would expect on atheism of the fundamental laws is either way more complex than we see or way more simple than we see. And so the fact that we get the laws, the level of complexity that we get happens to be in this Goldilocks zone where it is complex enough to support and sustain interesting structures, but it's simple enough to not
That's useful. That's a useful characterization. Okay,
right.
but so my issue there.
Given that we had, like roughly 3 topics we wanted to cover, maybe we should wrap this up in a few minutes. But also, yeah, I'd be happy to just keep.
That's fine. I'm happy to move on. I do like your characterization about the Goldilocks zone. I think that clarifies my confusion before when I said you were jumping between 2 topics. It was sort of looking at the issue from 2 different directions, which is that laws have to be complex enough, but also to support life, but also simple enough to support induction. So I think that's what I was getting at there. And that's helpful to phrase it that way. I think my general objection is I just have very little confidence in the sorts of inferences that you're making. And while I agree at extremes, like the examples I gave before, I think that in order to say that the complexity of our current laws is unexpected, you need to have a kind of a measure of what your prior is over these range of laws based on their simplicity. And I mean, clearly mine is different to yours. I feel like your justifications for your particular measure aren't very strong. What they establish is that there's, at least in some cases, there's some preference for simplicity, and that in extreme cases, we're going to need to appeal to that to rule out a lot of very ad hoc sort of behaviors. But to me, that's just not sufficient to establish that we're in this Goldilocks zone. Because, I mean, again, think about all of the different sets of credences I could give to like different sets of laws based on their simplicity, like how much of a weight I give simplicity, essentially. Are we really going to be able to rationally rule out those that don't make can we sufficiently rule out enough of those so that we're going to be confident in saying, yes, we can rule out these credences that and end up at the position where the current amount of complexity that we see is highly unlikely. I don't see the arguments for that.
Yeah. Okay. So several points. First of all, let me first agree with you. You certainly can have a way of assigning priors that gets a very high credence in having laws with a level of complexity similar to our laws, right? Let's say, just to make it simple, let's imagine that let's say that every set of laws gets ranked in terms of simplicity, and let's say ours is level 10. And what you could gerrymander some way of deciding upon priors where you say that there's just a massive bias in favor of 10 because more than 10, you just have too many, it's too complex. Less than 10, there are so few theories that just there's a large bias in favor of 10. But I think anything that does that is going to be very gerrymandered, arbitrary, and implausible, where by far the most natural ways of assigning priors either result in dominating in the simple laws or the complex laws dominating. It's very weird for the laws that we have, which are sort of, it looks like in the middle, to dominate. Now, maybe you said, well, maybe we're not, we're not sure exactly how complicated the fundamental laws are. Maybe they're a lot simpler than we think, or maybe they're a lot more complex than we think. And fair enough, we don't know the exact level of complexity of our laws. But the point is, so what really calls out for explanation is the fact that the laws sustain life. And the point is that there are different ways of assigning priors where on most of them, either you'll either get a big bias in favor of the simple laws or a big bias in favor of the complex laws. It's possible that our laws are very simple, but if so, then it's improbable that we happen to get one of the few simple laws that produces anything interesting and valuable, rather than the laws that just say the stuff doesn't do anything or the stuff just moves around in a circle. And to the extent that our laws are more complex than we think, then it's improbable that we get the particular laws we have where we can make pretty good generalizations rather than getting where everything's chaotic because there are an infinite number or millions of laws. You need, and the last point is you are saying you don't know exactly, it's unclear exactly how to balance the comparing simplicity. I think you need a very strong bias in favor of simplicity to have a low credence in the infinite number of ways that induction could fail 1 second from now, right? Given that there are an infinite number of laws that would result in induction just totally unraveling 1 second from now, or 2 seconds from now, or 3 seconds from now. In fact, there's a higher cardinality of infinity worth of laws, at least Beth 1, because you could have it. Well, actually, I don't know. Let's not get into infinities, but there are at least a huge number of ways that the laws could spontaneously unravel 1 second from now. And so if that's right, then you need a really big bias in favor of simpler laws, and then it's very miraculous that we have laws that produce anything interesting. When the most probable scenario would be one of the huge numbers of very simple laws that don't produce anything interesting. The last point, and is that I think that we can see conceptually that just even if we know with certainty that the sets of laws, let's say that our laws are kind of medium level complexity, I think we can see that whatever the level of complexity of our laws, it's very unlikely that things that have that level of complexity would produce anything interesting, just because of the core insight that it's very difficult to get a system to produce anything interesting, even if you can have a lot of laws. John Conway famously, he had his game of life. For those who don't know, you sort of place down dots and they move around according to simple laws. And it produces all these interesting and elegant patterns. But he had to work really hard to find a set of initial of laws that govern that. And in order for it to produce interesting things, you obviously need the initial conditions, the set of dots to be finely tuned. And so I just think if you just wrote just a random code for stuff moving around, it's very unlikely it would produce anything interesting. And that's the sort of core conceptual point. And so even putting aside the stuff about complexity, it's just very unlikely that the system would produce anything interesting or valuable. Sorry, I know I said a lot.
Yeah, well, I think we should discuss that point, like the Conway's game of life point, a little bit more. I guess that kind of does relate to the second point. It's not exactly the empirical evidence about the constants, but it's related to that more. I did want to just mention something briefly, which is that there are further issues I have about what is a law, like a fundamental law, and also like a lot of your examples about inference appeal to induction failing at different points in time, and I think that there's that depends on the particular sort of notion about what time even is, which I'm sort of uncomfortable with. I don't want to get into those issues here. I just want to sort of footnote them if people may be interested for further discussion, or we can talk about them another time. But I just think there's more going on here that ideally should be addressed before and that's sort of one of the reasons that I'm a bit uncomfortable about these sort of inferences, is there's sort of a lot of metaphysical assumptions going on that I don't necessarily agree with. But yeah, we're not going to be able to address all those here. I also wanted to mention something from chat, which I know that we don't have to be slaves to chat, but I don't really care what people say about me, with perhaps one exception. I don't appreciate being characterized as a bad faith actor. So if people think that I've said things that are in bad faith, feel free to sort of mention them and I'll be happy to explain what my position is. But, you can call me ignorant or wrong or whatever, but I really don't like being said to be in bad faith unless you can provide some good arguments for that. So, yes, I just wanted to.
I want to say I don't think you're in bad faith. I think you're wrong.
Well, that's fine. I mean, you're wrong every day of the week, but just that particular accusation irritates me when there's no backing up. I know you haven't said that, but a couple of people in chat are saying it, so I thought I'd mention it.
I mean,
anyway,
your compadre Nathan, he said that about me, but.
Well, that's an issue you can take up with him, right? I'm not going to get into that.
I don't know.
But anyway, so why don't we talk about this idea that it's very hard to make a system that does anything interesting, or that like has the complexity necessary for life. So the game of life example is interesting because I think the rules there, I don't remember exactly what they are, but they're relatively simple. It's a two-dimensional world, and it describes what happens when there's a certain number of the rules only relate to the number of surrounding cells for a given cell that are alive or dead, right? So if there's less than a certain number, between this number and that number, then a cell can become alive or it can die, something like that. It's very simple compared to the equations of the fundamental laws of physics. And so one interesting aspect of that is that you can observe very complex behaviors, self-reproducing structures and things like that, even in such a simple world. The sort of contrary observation is that, well, yes, you can, but most structures that exist in that world like don't do anything interesting. You have to start with the right set of sort of cells turned on and off. Plus, Conway himself had to sort of fine tune the laws to produce something interesting, because most of the laws didn't produce any interesting patterns. So the sort of inference being made here is, yeah, you can get complex behaviors with relatively simple laws, but the laws and also the initial state kind of need to be fine tuned, because most of the time that doesn't happen. So is that a fair characterization of how you describe that example?
Yeah, and just note, so John Conway, the Game of Life, I just looked it up, there are 4 rules if Wikipedia is to be believed. And
yeah, that
so
sounds right.
That was right. Yeah, and if you just delete any one of them, nothing interesting will happen. And he had to work really hard fine-tuning the rules so that they produce anything interesting, because the vast majority of, he tried with all these things about hexagons, none of that worked.
So,
yeah,
I didn't know
good,
that.
Good summary.
Yeah, okay. So so the issue there is, what does it tell us about the existence of life, or like the range of possibilities in which life can exist? Honestly, I'm not sure what it tells us. I think one lesson I take is that it's very hard to predict what complex behaviors will emerge from a given set of laws, because most of the complex stuff you see with the set of laws that he did sort of finalize on, most of those you wouldn't be able to predict just by looking at the laws. It's sort of highly counterintuitive, right? So to me, there's a lesson there that it's hard to predict the it can be hard and counterintuitive to predict the behaviors of even fairly simple sets of laws. But on the other hand, there's the lesson that you point out, which is, yes, but he had to fine tune the laws, and most sets of laws, at least that have been experimented with, don't produce anything interesting at all. So even, you might say, look, even if that there's many many types of laws of like physical laws, even if in many sets of physical laws there are forms of life that we wouldn't be able to, or there are possibilities for the emergence of life that we wouldn't be able to predict, those will still be grossly outnumbered by the possible sets of laws in which there is no possibility of any complexity, whether we could predict it or not. So I think that's the inference you'd be inclined to make.
Well, it's not necessarily that with most of the laws you could predict in advance that they don't result in any complexity. It's that most of them would not in fact generate any complexity, right? So for most of them, you just look at what they describe, and it's hard to have any firm intuitions about it. But then when you let them run,
well, that's what I'm saying.
Oh, okay, sorry. Maybe.
So in Conway's Game of Life, you look at the laws, I don't really believe that many people would predict what, like, without having heard about the case, right? It's just not obvious that you would see that. And yeah, in Conway's Game of Life, we can try different laws and see what resulted. But my point is, obviously, when we're talking about different laws of physics, we can't, at least in many cases, we can't do that. We can look for specific phenomena. This is one of my criticisms of the empirical evidence for fine-tuning, is that we can look for specific phenomena that we know exist in our reality, but we don't necessarily know what other phenomena we're not looking for, because we don't know to look for it, right? And Conway's Game of Life, I think, illustrates that there can be complex things that you wouldn't have even sort of expected to look for. And because we can't actually run these simulations with alternate physics, and work things out through to their conclusion, I think we should be fairly skeptical about knowing too much about at least many of these. But I think so that's one of my arguments against the empirical evidence. But your conceptual point is that, look, even if it's true that there are many types of sets of laws that would lead to complex forms of that could sustain complex forms of life that we wouldn't be able to predict just by looking at them, even so, those will still be outnumbered by the number of times in which there isn't anything interesting. And so that's the lesson from Conway's Game of Life. So I think I think that inference is probably stronger than the actual empirical evidence for fine-tuning, ironically, because I mean, many people have given very high probability figures for sort of how unlikely it would be to observe life given the fine-tuning range. But because of these uncertainties about what actually would exist in these different with these different constants, I'm sort of very skeptical about those. But I think this conceptual point, at least to an extent, obviates those concerns. But sort of what I'm thinking about is, or what I'm honestly not sure about myself, is to what extent does it obviate those concerns? And one issue there is that there's this it seems to me there's this tension between simplicity and complexity, and sorry, not simplicity and complexity, simplicity and predictability. And so take Conway's game of life, right? The laws there are quite simple. We can simulate what happens if we change those laws, add one, delete one, etc. And we can see what happens. But when it comes to the actual laws, like the laws of physics as we currently know them, we can't do that, at least in the vast majority of cases. And so the question is, what can we say about what would exist or what possibly could exist if say, the constants were different or if the laws were different? The issue that I have is that the complexity in this case is much higher. And to me, that there is a potential there for the higher the complexity of the set of laws is, the potential greater range there is for unexpected phenomena, because there's more degrees of freedom in the system. So if the predictability is less, then we should perhaps be less confident that we know whether there can be complex life in that system. In Conway's game of life, obviously we know that because we can simulate it. We can work it out. But we can't. My claim is we can't actually do that with the real laws of physics, at least in the vast majority of cases. And therefore, because the complexity is so much higher, our confidence that we know what would happen, or that we even know what the probability measure over like what would happen is, like, oh, well, we can say that only a small proportion of them would support complexity. I think that we should have diminished confidence in that.
Yeah. So, first, let me start by agreeing that I think that this sort of conceptual point about how, you just sort of look at simple models and of trying to have relatively simple systems produce interesting things, ones that we can get a handle on. Most of them are very fragile in the sense that if you tweak the parameters slightly, if you tweak the laws slightly, I agree. That's way more convincing than the fine tuning of the constants in physics. Well, I think it's more convincing. I don't know if I'd say way more convincing. I think that the best version of fine tuning is that this conceptual point is more convincing than the.
Well, it's an actual demonstration of fine tuning, at least in that case, because you can actually show what would happen under the counterfactuals, which is one of my major criticisms of sort of the empirical evidence for fine tuning. So we can actually show across a certain space, most of these don't support complex behaviors. So that's an interesting insight. I guess my issue is, let's extrapolate that out to a much more complicated system. Do we think that the same pattern will hold? And I'm pretty reticent about that generalization.
Yeah. Well, so and I couldn't go into into this in any detail, but my sense is that the pattern that holds in Conway's game of life, where you look at the systems that produce interesting stuff, and then you look at sort of like, okay, whether there are similar things, whether there are similar ways to, whether them producing lots of interesting and valuable things is a probable result of things with that level of complexity, or whether you have to really work to find one of them that produces anything interesting. And sort of my sense is that this is true for a lot of things. Other people have tried to make similar simulations. It's true with our laws of physics. So, for example, if you delete any of the laws, with I think the exception maybe of the weak nuclear force, then no life could arise. If there was no gravity, everything would just go shooting off into space when it starts moving in one direction. And so I think that just explanation of this is that there's just this general principle, which is that interesting and valuable things are rare, and it's unlikely that you'll get them, which is why which will to the extent that you have them, it'll favor fine tuning for them. I disagree with your worry about the impossibility of about whether we're right about the universe being finely tuned. You say, well, we're not really sure about the counterfactuals. I mean, I'm not a particle physicist, but my sense is the particle physicists have been able to figure out what would happen under different conditions. So, for example, if the cosmological constant was a lot stronger, given that the cosmological constant governs sort of how fast stuff, how fast everything's expanding and pushing away, if it were stronger by, an order of magnitude or something, then just everything would quickly fly apart. And if everything quickly flew apart, if, there were no planets, no complex things, everything was just atoms not interacting, just fundamental particles shooting off into space and not interacting, then clearly you couldn't have any life or anything of interest or value. And if it were a lot weaker, everything would implode. And then if everything imploded, you also couldn't have anything of interest or value.
Yes, I don't know how fruitful it would be to discuss those examples in detail in this context, especially because it seems that even if all of those failed, you would still make the argument on the basis of the conceptual point anyway. So it seems more useful to focus on that. But and as I said,
Yeah,
I
well,
actually think it's stronger as well.
yeah, well, just to be clear, I think that there are two bits of the fine tuning stuff, two ways in which the world is finely tuned that both call out for explanation. One of them is just that there are sort of interesting and valuable and complex structures in the first place, that there's conscious life at all. And then second is that we have fragile laws. So we have laws that are such that if you tweak them slightly, nothing interesting or valuable could arise. And I think that each of these calls out for explanation, and theism is the best explanation for both of them. Though the first one is more striking and less explicable by other things. So I think the a priori point is stronger, but I think both of them certainly have force.
Well, yeah, I don't agree that it's established that our I don't agree that it's that we know that our current, well, they focus on so laws are fragile in this sense that if you change the constants, yeah. So I don't agree that it's established that our laws are fragile with respect to the existence of valuable complexity like life or something like that, because astrophysicists, particle physicists, they don't know anything about how to look for that in fundamental laws, and this is the point that I think is just never appreciated. What they know how to look for is whether atoms can form or whether stars can form or things like that, but that's not what does that have to do with the existence of valuable complexity?
Yeah,
that's just what we know is required in our universe. Yeah, but to me, that's like going to the bottom of the ocean and saying, "Well, I don't see any tetrapods here, so there can't be life."
Like, wait, sorry, what's
that's ridiculous. Something with 4 legs, right?
Okay. Yeah. So I don't think that's true. So I think the best case of these for it being very clear that life couldn't arise is the cosmological constant, where it's just either everything shoots off into space, nothing interacts, or everything collapses in on itself and becomes super dense and no interactions. Either way, you can't get any interesting things. I think there's some where it's less clear, right? So there's some stuff about, okay, stars wouldn't form, you wouldn't have heavy elements, where things would just be a cloud of hydrogen or helium. And then, okay, could stuff form if there was hydrogen or helium? Well, I mean, it's not impossible, right? Maybe there are other forms of life, but I think we should think it's very improbable, right? And if you don't think it's very improbable, then you should look inside. We should be doing a lot more searches for life on the surface of stars. If you think that, or in clouds of hydrogen gas, if you think that just even absent heavy elements forming, that's just like a cloud of helium can produce.
No, life. I don't think it. Well, I don't think it's going to be helpful to get into that. Let me just let that slide.
Okay.
The point, just for seeing a half-hour conversation, it's not really that helpful.
Yeah, sorry. Just for reference, we were gonna roughly how long should we go for?
Well, I was envisioning between 90 minutes and 2 hours, somewhere in there.
Yeah, works for me.
Yeah. I think that's a good length for these discussions. Oh bugger, what was I was going to say something about what you said. So you're talking about, lost my train of thought now. Before you said about looking for life on stars, what did you say before that?
I was talking about the cosmological constant.
Oh, the cosmological. Yes, that's what I was. Yeah, thank you. Yeah, well, so that's an interesting one, right? So because again, I've never understood this argument. It's so, well, for one thing, the cosmological constant is one of the least well understood. We don't know sort of why it exists, and the best calculation for it, which is based on the vacuum energy, is off by like 120 orders of magnitude or something like that. So I think we should be kind of suspicious of it. It's sort of like just having a bit more humility about that we understand these things very well. But even putting that aside, the idea is that, look, if the universe collapsed too quickly, we couldn't have life, or if it expanded out too quickly, we couldn't have life. But I mentioned this in my video. How do we know what the time span is for life? Well, we don't. We're just basing that on what the time span is in our universe. But when we're talking about varying all of the different constants, I don't think we can say what the time span is, whether it's in nanoseconds or in billions of years. Like, that's just an assumption based on what we know. So I just find these sorts of inferences very implausible. They're just based on wild extrapolations from as far as I'm concerned.
Yeah. Well, so let me first address... wait, now I'm forgetting the point. What was the first the first point?
The first thing I said is we don't know very much about the cosmological constant.
Oh yeah, so I think I'm
kind of suspicious of any inferences that appeal to it, to be honest.
Right. So we
or
don't know like
any of these sorts of inferences.
what causes its value. You know, there may be deeper physics that fixes it and so on.
Yes.
Is that, just to be clear, that's what you mean when you say we don't know about the cosmological constant?
Well, really anything.
Well, like
but
we know
yeah. Yes.
yeah, right. I mean, we know like that the like we know like what the
We can measure its value. Yeah. That.
yeah. Okay.
I don't mean
Right.
that.
So I don't think that this point about how there might be deeper physics that fixes it is very convincing. So here's an analogy. Imagine we discovered that the initial conditions of the universe spelled out, made by God. Seems like that would be, you know, strong evidence for the for the existence of God. But if you can always say maybe there are deeper physics, we don't really know what fixes it. But the point is, given that the deeper physics could fix it to be any of the range of values, it doesn't actually affect the epistemic probability of it taking on that particular value, because it's so unlikely. It's very unlikely that the deeper physics would fix it to be the particular value that it is. And similarly with the cosmological,
well, we don't know. That doesn't make a lot of sense to me. But anyway, keep going.
Yeah, with the cosmological constant, it's very unlikely that the deeper physics would fix the cosmological constant to be such that it produces, that it falls in this narrow range where it produces interesting and complex kinds of life.
Well, I don't. I'm not ready to make that inference, but whatever.
Well, so what do you make? So you agree that it would be illegitimate to say, if we discover that the initial conditions spelled out made by God, it would be illegitimate to say, well, maybe this doesn't call it for explanation. Maybe it's explained by deeper physics. Do you agree that that would be an illegitimate inference to say?
Well, that's actually what I was suggest we transition to, talking about
the
divine, the sort of divine inference part of the argument. So this is similar to an example that Luke Barnes gave in a debate I had with him a couple of years ago, actually, about he didn't give the example of the initial conditions of the universe, but something about I think the stars viewed from Earth spelled that out. This is going to get to a complex issue, which is essentially sort of design inference and what constitutes a better explanation. So, because I'm not sure actually what that doesn't express what I want to say. I don't think that theism predicts that the initial conditions of the universe or the configuration of the stars or anything like that from Earth would spell out made by God in English, right? So I don't think that's a good explanation. Now, if I were to instead say, well, it's physically necessary that the initial conditions would be like that or something, that doesn't seem like a very good explanation either. So at that point, I'm not sure what a good explanation would look like. Maybe you could say, well, they're both bad, but maybe one is worse than the other. Well, I'm still to be convinced that that's the case.
Yeah. So I agree that they're both bad explanations in the following sense. Conditional on theism, the odds that the initial conditions of the universe would spell out in English made by God are quite low. And conditional on naturalism, they're also quite low. But I think the odds are astronomically higher conditional on theism than on naturalism. Like you can imagine God wants to leave a sign. Now, maybe this would favor the alien prank hypothesis, or like we're living in a simulation made.
That's actually, yeah. So that's the inference I'd be inclined to make. I think that those are much better explanations for these sorts of phenomena. But people don't take that seriously when I postulate it, I've noticed. I don't know why, because to me, these ridiculous scenarios are much better explained by some weird prank of a simulator or aliens than either design or just sort of chance or something. But I'm not going to strongly push that, right? But I honestly, like, the point is, these are really bizarre scenarios. And so I don't think it's a problem if I resort to bizarre explanations, as long as we can establish like the criteria that are being used to assess that. And my point is that God just doesn't do the trick. It doesn't explain those phenomena well. And that's what the fine-tuning argument is supposed to do.
Yeah, well, I mean, a personal explanation of a phenomenon almost never will make that phenomenon probable. But nonetheless, you often have very convincing evidence for a personal explanation of the phenomenon, right? So, if I see a handwritten note on my desk that says it was written by my brother who, said, I'm leaving to go to the bank, the prior probability of my brother writing that exact note is infinitesimal, right? What are the odds he'd use that exact wording? But nonetheless, it's way more likely than that would be generated by, for example, a random ink spill. And so now I agree with you. Maybe in the case of it spelling made by God, it would just be such a weird feature of divine psychology where like he cares a great deal about being hidden, right? But then he randomly has the initial conditions spell out made by God. I agree. Yeah. So maybe that would favor the simulation hypothesis. But my point is just that I think that it would be a bad explanation to say that perhaps that's explained by deeper physics because we don't know what causes the initial conditions. That would be a bad explanation, just as it is a bad explanation to say that deeper physics might fix the cosmological constant, because the point is, given that you can imagine deeper physics fixing the cosmological constant to be any of the ranges that it could be, including the non-life permitting values, the probability that it would fix it to be in the life permitting values is very low, just like the probability that the deeper physics would fix the initial conditions to spell it made by God is very low.
I'm struggling to understand what you're meaning, what you use, what you mean when you say probability in these contexts. Actually, that's another. I think we had that discussion actually in the previous debate, so maybe we shouldn't get into that again. Yeah, maybe I'll just let that one go and say I'm not sure about the use of probability there, because to me, if we have an explanation that renders something reasonable, then asking, well, yeah, that doesn't articulate what I wanted to say. Okay, let me say it differently. If we find out that certain laws are physically necessary, then asking, well, how probable is it that those laws would be physically necessary? I just don't know that there's much substance to that.
Well, but
so we have an explanation of why let's say we have an explanation in terms of physics as to why what we're talking about, the cosmological constant was a certain value, but then we're going to ask, well, what's the probability that that explanation would exist?
Right. Well, so you're saying
but that can be done for any explanation of anything.
Right. So you're saying it doesn't make sense to talk about the low probability of the physically necessary laws taking on some value. But do you think that it's similarly illegitimate to talk about the low probability of the initial conditions spelling out made by God? Because I struggle to see what the symmetry is between, or what the asymmetry is between those two things.
Yeah. Well, this is the thing. It's going to get into what we mean by these probability statements, because if we're using an epistemic notion of probability, which I understand you are, then you can assign probabilities to anything. But I mean, my concern is that there's not actually a strong constraint on what those probabilities have to be if they're subjective. And so I would ask, what evidence are you conditioning on? And the idea is, well, I'm not conditioning on any evidence, it's a priori. And I'm going to say, what even is the substance of these probabilities that we're arriving at? It just sort of seems irrelevant to me. But I think I don't know if this is crucial here.
Okay, yeah, sure. We could move on to a different topic.
But I think it's maybe in terms of moving the discussion forward, instead of talking about the probability, you can say we can talk about giving an explanation for something, because you've used that terminology before, right? So if we could say, suppose that the initial conditions of the universe somehow, I don't know, in the concept of background radiation spelled out, made by God or whatever in English, we could ask, what's an explanation for this? Or how do we explain this, right? I think that's a reasonable thing to ask for. And one possible candidate explanation could be that to say, well, the initial conditions and the laws, let's say, that gave rise to this are physically necessary, so it couldn't have actually been any other way. Now, you're going to say that's a poor explanation. Maybe so. Another candidate explanation would be to say, well, God made it that way. Another candidate explanation might be that we live in a simulation. The simulator thought it would be funny, so he made it that way, right? Or aliens have made it so that it's not actually that way, but like it looks that way from our perspective, or that they've sort of played a trick on us or something like this. So I guess what I think that's a reasonable exercise, right? Prior probabilities, I guess they play a role there. I think that there's issues with the talk of probabilities there because of what you're conditioning on. But I think it's fair to talk about how do we explain these sorts of things.
But I mean, I think that the reason why the initial conditions spelling out made by God, why that calls out for explanation, is because it's improbable and that there are other better explanations of it. right? So you should think almost certainly, if you see that, almost certainly that wasn't just by chance. Almost certainly that was either because of a simulator, an alien, or God. It was almost certainly.
Well, the thing is, if something's physically necessary, it's not by chance. So that doesn't rule out physical necessity.
Okay, right. So then let me rephrase. It is almost certainly not caused either by chance or physical necessity.
Physical necessity isn't even a causal.
It is
causal.
not almost certainly not explained by chance or physical necessity.
Yeah, but that's sort of kind of question being around. If I look at, I mean, how do you know? Well, how do you know when you look at something that sort of seems intuitively implausible that it's not explained by physical necessity? Like, I don't know how you'd make that assessment.
Well, I mean, because the prior probability, if there's some other reasonable explanation of it, then the prior probability of that particular very specific arrangement being physically necessary is much lower than the prior probability of something else being physically necessary.
Well, now we've gone back to prior probabilities, and I'm a bit lost because I don't know where those assessments have come from. It seems to me that actually what's happening is if we were to look and see made by God, in the cosmic background radiation or something like that, we have a strong tendency to invoke a design explanation in favor of that. I'm not saying whether that's appropriate or not. I'm just saying that that's a very strong reaction we would have to that phenomena. And in contrast to that, it seems that an inference to physical necessity is, even if the design inference is acknowledged to be fairly implausible, in comparison to that, we feel that an inference to physical necessity is just way less plausible. I think that's really what's going on there. And you can phrase that in terms of prior probabilities, but I think it's sort of probably different ways of describing the same thing.
Yeah, okay. Right. So I mean, I think that the best way to think about these things is in sort of Bayesian terms and assigning prior probabilities. But sure, if you're uncomfortable with prior probabilities,
Bayesian terms doesn't tell you anything about how to assign those prior probabilities, and that's part of my issue there.
I mean, I think you'll assign prior probabilities by looking at simplicity.
Well, we just had a whole long discussion about that. So I don't want to rehash that. The point is, that's just a gesture at some of the reasons why I'm a bit skeptical about that approach in contexts like this. But that's fine.
All this talk about prior probabilities. My point is just, I think that saying it might be deeper laws that bring about the cosmological constant when it falls in this narrow range out of this huge number of values that it could have taken on. I think that that's improbable for exactly the same reason that it would be improbable if the initial conditions spelled out made by God, to say that maybe there are some deeper laws that result in the initial conditions spelling out made by God. A better explanation would be like the simulation hypothesis.
Yeah. Okay. So a better explanation would be, so you're basically saying it's a poor explanation. Yeah. So let's talk about the design case there. So someone in the chat said to sign their work doesn't need to be probable that God did this, only not astronomically improbable. Okay, so this is, I think, a similar objection that's Luke Barnes said almost exactly the same thing. And I have a real issue with this type of inference. I think, well, yeah. So it goes something like this, and I think you've said something similar, right? It's that any design inference is going to be, look, it's pretty unlikely God would do that, right? But it's even less unlikely under naturalism, or by chance, or however you want to phrase that. And so therefore we prefer the design inference. Do you think that's fair characterization for these sorts of
I mean, so I think that, yeah.
I mean, you said this before, they're both unlikely, but one is even less unlikely.
Yeah, like, for example, I think with the cosmological constant, suppose all you
I don't want to talk about the cosmological constant. I want to focus on specific design inferences, like the message in the skies or the existence of life, perhaps.
Yeah, right. So yes, I think if it spelled that out, then even though that particular message being signed by God would be low probability, it would be even more improbable for that to arise just by chance, just like in the case of the note written out.
Yeah. Okay. So there's an interesting symmetry here to the earlier part of our discussion, because when we were talking about what is reasonable to think about different sets of laws, like simplicity versus predictability and that sort of thing. And you were arguing we should have this set of beliefs about how probable different things are, and what the sort of scaling is for simplicity versus probability and things like that. And my general reaction was, I don't think we know enough about sort of any of these things to make those sorts of inferences. Now, I'm going to say something very similar here. In fact, maybe even push it more strongly here, because we're dealing with God, which is much more complex and even, well, much more beyond our understanding, let's say, than any potential laws of physics, since God's supposed to be, infinite and all that. So the question I would ask is, how do we assess the probability or the likelihood or the quality of the explanation of God, let's say, signing the cosmos in the way that's been suggested? God did this in the cosmic background radiation. How do we assess that, right? Because we're making an assessment that it's unlikely, but it's less unlikely than under the sort of naturalism possibility. And I want to ask, how do we make that assessment? Because if it's purely intuitive, I'm not really going to trust that. Because my sense is that the range of things that's possible under God is actually greater than the range of things that's possible under naturalism. That shouldn't be controversial, because God can actualize any natural state of affairs, plus he can also actualize many things that exceed naturalism.
Certainly
so
the number of possible worlds that there could be with a God is greater than or equal to the number of possible worlds there could be under naturalism. I imagine they'd both be infinite, but
well, that puts a spanner in the works, but I don't like talking about infinities because I think they can be very difficult. But the point there being, though, that there's things that God can actualize that would be inconsistent, would be ruled out by naturalism, right? And so why is it that then this particular outcome is more likely under theism when there's even more possibilities of other things that could theoretically exist, or that could conceptually exist?
Yeah. Well, so I think it's very unlikely. So, if we just sort of speculate about divine psychology, what's true that the probability, if we just think about, okay, what would we expect God to do? The probability that we would assign just from the armchair of God having the initial conditions spell out made by God is not high, but it's way higher than the probability, I think, that we would assign to it on naturalism. You could at least, you could imagine a reason. Maybe God wants to alert us of his existence. Maybe he wants his existence to be the type of thing that becomes clear once we get really advanced science, but not to early primitive people, because early primitive people use it for bad reasons. You can come up with all of these speculative explanations, none of which I think are that probable, but like they're going to be, maybe like 1 in 100 million or something.
Where does that number come from?
Well,
I know you're going to say, well, it was just an example, but this is actually the point, right? I think, I mean, maybe I'm not good at communicating this point. Maybe it's just wrong. I don't know. But I feel like people, when I make this argument, they just don't, they just think it's ridiculous, right? Because they'll say what you're saying. Oh, well, at least I can come up with speculative reasons that God might have. But of course, I mean, my argument would be, but you could come up with speculative reasons that he wouldn't do that or would do something else. And so you need to think about, well, what's the space of possible reasons that he could have, right?
Yeah.
And so that is vastly enormous, right? Just as you're going to say, but the set of possible background radiations that could exist under naturalism is vastly enormous. So is the set of possible things that God could do. And my argument is it's bigger because he's not constrained by natural states of affairs. And so if you're going to apply this is what I said in my video. If you're going to apply the same type of inference as you do to naturalism to say that these things are very unlikely, you should also say that they're even less likely under theism, unless you make certain assumptions about divine psychology. And then my argument would be, but what's the basis for those assumptions?
Well, I mean, so if we think that God is a perfect being, then we can speculate on what are the types of things that a perfect being might do. I think your objection, if we took it seriously, I think it would fully eliminate the possibility of ever coming to any probabilistic conclusions about anything, right? So here's
that's a strong leap. How does that follow from what I said?
Well,
we're talking about God and the initial conditions of the universe.
Well, so,
and if I'm saying it's implausible to reason about that, you're saying, well, we can't reason about anything.
Yeah. So here's an explanation different from so here's the common theory. J.K. Rowling wrote Harry Potter. Here's another theory. A bird flew onto her typewriter when she wasn't home and kept stepping on her typewriter such that it typed out every single one of the words in Harry Potter. And then she got home, she had this magnificent work of fiction, and so then she sold it off and thought, and was very grateful to the bird. I don't know exactly what the probability is that J.K. Rowling would write Harry Potter. Whatever the probability is, it's astronomically low, given that how specific Harry Potter is, how many words there are, but it's way better than the bird hypothesis. And so if you say, well, I don't know, we'll have to be, doing the speculation about J.K. Rowling psychology, and, how do we make comparisons? If you're skeptical of our ability to make these kinds of comparisons, then I think that you would also...
I think that's a silly comparison. But I don't mean to be rude, but I think... So I feel this is similar to what you did before, right? So you take an extreme case, before we talked about the universe, like a very extreme case, and say, well, if a universe was that simple, not going to be any life, and it's also going to be very predictable, right? And then we talk about very complex cases, and then everything in the middle just gets sort of hand waved away, and we say, well, somewhere we sort of work that out, and I think something similar is happening here, right? I think there is a vast range of theory and background knowledge that we can appeal to explain in virtue of why we make the inference that J.K. Rowling and not some random bird wrote Harry Potter. I don't think I even need to explain that. Everyone knows what I'm talking about when I'm appealing to those sorts of things, right? What is the comparable knowledge that we're appealing to when we're making inferences about divine psychology?
So sorry, when you say... So I agree. I agree. We shouldn't think J.K. Rowling wrote, or we shouldn't.
But the cases, what I'm saying is the cases are not comparable because we have theory and knowledge that we can deploy when making inferences about who wrote something. We don't in the case of God. What theory do we have to work with in the case of God?
Sorry, when you say we have theory and knowledge about who wrote Harry Potter, can you elaborate?
No, okay, so we know people write books. That's part of our background knowledge. We understand the process that people have brains and that they have fingers that they press keys on and that you can think of ideas. And we could look at, well, where did you get the idea of witches and wizards from? Well, that's part of, the history of ideas in Western civilization. So we can see where she got that idea from. And you can look at her life and look at, people know that she was like an author and interested in those ideas. And like, I don't know what exact things I'm allowed to appeal to and what's part of the issue of probabilities. Right. I don't know what I'm allowed to condition on, but there's and we know that the probability of crows randomly typing on, like landing on certain keys is overwhelming. Like when you multiply that out, it's extremely unlikely beyond a very small number. We can compute that based on very reasonable assumptions of like birds and their intelligence and how they would stand on keys and all of this sort of stuff. Right.
Yeah.
So that's just not analogous in the God case where we don't have any of that knowledge.
So the two things you said were, first, you pointed out that we can compare, we know books are written exclusively or almost exclusively by authors. Maybe they're sometimes written by AI or something, but basically by authors. I mean, one thing is, it's if we take this seriously, it's unclear how we would know that, because how do we know that most of the books aren't getting?
Well, you're not going to ask me to justify all of human knowledge, right?
No,
can I have a baseline of things that we?
No, look, the point is not about justify epistemology from first principles. The point is that we very often do. It's very often the case that there are two things that are very low probability, but we can just see by thinking about it that one of them is that they're both astronomically improbable. J.K. Rowling writing exactly Harry Potter, all the particular words in it, is astronomically improbable, but it's way more probable than the bird writing Harry Potter.
I agree. And
And
my question is, how do we make that assessment? And I think that we can explain how we make that assessment by appeal to background knowledge. Well, okay, what background knowledge do we appeal to in the case of God?
So I think that we can appeal to some more sorts. So the type of background knowledge that you appeal to was like, we know, books are books that are written either by people or birds are written exclusively by people. And
I think we can probably say better than that, actually, because we can actually calculate the probability that Harry Potter, even just the first book, would be written. We can calculate the probability that a bird who just happened to land on the typewriter would actually stand on the keys in that order, with some pretty reasonable assumptions, about how that system is supposed to work. We could actually calculate that. And then we could compare the probability that a human would actually write, because humans have a very different process of selecting words, or actually individual characters. For example, when a human is typing THE to say the probability of putting an E in that location is very high because of the conceptual knowledge that they're bringing to bear and, the fact that they want to say that. Whereas a bird doesn't have that. It randomly stands on the keys, right? So we don't need to do that full calculation, but we have more than enough background knowledge to actually make that very firm assessment. Yeah. But I don't think that's the case in the case of God. That's my point.
In the case of God, right, so your point was like, so right, we could do an advanced a sort of hand wavy calculation where we look at the probabilities and come to a more precise conclusion. But obviously, we know that the burden knew it even before doing that calculation, because
Yes.
we can see that just one of the probabilities is way lower than the other probability. And I think we can also see it in the God case. Now, in the God case, you're asking, how do we see it? Well, I think we can do a similar thing by appealing to a reference class. So one thing that we can see is, look, agents sometimes leave messages. They sometimes they sometimes leave messages that have their name. And in fact, everything that looks like a sentence that's ever been made has always been made by an agent of some sort. Every sentence ever written has always been made by an agent of some sort or by an AI, right? But and so if that's true, then if it spelled it out by applying that similar reference class principles and generalizing from the things in our experience, we could say, okay, it was almost certainly written by an agent on similar.
I actually think that's reasonable, right? And I actually think that's reasonable in the case of the cosmic background radiation with the message in it, right? It would be reasonable to infer that the reason why we make this observation is because of the work of an agent. But that's not my issue. My issue is ascribing it to a divine agent.
Well, so then we have to look at the probabilities of different agents, right? So it could be a limited agent that does it. I agree that it spelling out made by God that's probably better predicted on the limited God hypothesis. The claim would just be that we have independent grounds for thinking that an unlimited.
Okay,
God
yeah. So maybe now. Sorry to interrupt.
Is more likely than.
Well, I just said yeah. Maybe that's a good place to transition to something that you think is an example that is best explained by the God hypothesis, like the divine agent as distinct from a different agent, because I can agree that certain observations may be best explained by an agent, even if they're not well explained by an agent, and even if we don't know the nature of the agent. But then the issue is, how do we assess any particular observation as being due to a divine agent?
Okay, so I mean, this might get a bit outside of the scope of the discussion. I think the things favoring a divine agent over a limited agent of some sort are, number one, have I told you about the anthropic argument?
I don't think we've talked about that, no.
Okay, right. So I have an argument for theism called the anthropic argument, and the basic idea is that, so there are different theories about how to do anthropic reasoning, where anthropic reasoning is how you reason about your own existence. And I think that the best theory is called the self-indication assumption. And on the self-indication assumption, theories that say that there are more people are thereby more probable, right? So if there's a theory that says that there are 10 times as many people, all else equal, that theory is 10 times better because it makes it 10 times as likely that I would come to exist. And so if we accept that theory, then what we need is whatever the number of possible people there are, we need some agent, if we think there is an agent that explains it, that can bring about that many people. But if we have an agent that's powerful enough to bring about, best two people, or, that's able to bring about uncountably infinite people, then I think, once we have that, we have an agent with very immense power. And that's going to be better predicted on the hypothesis that there's an unlimited perfect God than that there's a limited God, because the unlimited perfect God is omnipotent. Now, maybe it's a God that is able to do that, but maybe can't do certain other things, or maybe is morally flawed. All of those are possible. I think those are going to be ruled out on parsimony grounds, and I also think a limited God is going to be ruled out on grounds of parsimony and elegance, where just a God who's unlimited in power, unlimited knowledge, and consequently unlimited in goodness. That's a much more parsimonious theory. It posits that there's just one fundamental thing, which is, I mean, there are different ways of cashing it out, but like just a single thing of unlimited goodness. So if we think goodness is fundamental, then a single thing of unlimited goodness is going to be simple. Now, this gets into complicated issues surrounding the complexity of God, but I think it'll certainly make it a better view than just a limited God theory.
I don't really want to talk about. Yeah, I've read a little bit about what was written about the self-indication assumption and those sort of anthropics. I don't really want to talk about that now, but I think it may be worth talking about the notion of the simplicity of God. Well, it is and it isn't. So
I don't know. I think
we
could talk about it, but I think maybe it would be a bit outside the scope of the discussion.
Okay, sure.
Yeah. Like, even if God's very complicated, that would mean maybe that theism has a very low prior, but it wouldn't affect how big of an update you get from fine tuning. It just will affect the prior probability.
Right. Well, I mean, that's fair, but that's a point that I don't really believe in just focusing on likelihoods, because I talked about this in my video. You can, it's not difficult to make a likelihood ratio very high by stuffing assumptions into your prior. So I think that that's kind of beside the point as to how big you can make a likelihood ratio. I think you need to look at the overall posteriors of the different posterior probability of different positions. Because I could just say, well, I postulate a God who made exactly this universe because he just felt like it. But that maximally predicts everything we observe, right? So if you're just looking at that likelihood ratio of that relative to anything else, really, it's going to win. But I think most would recognize that's not a good explanation, essentially because you've just assumed everything into the prior.
Right. Certainly, if you don't if you think theism has an extremely low prior probability, then even if you're convinced that fine-tuning calls out for explanation and is naturally explained by theism, you should go for one of the other explanations that you think has a higher prior probability, like maybe a limited God or a multiverse.
So I think it's not just theism.
Sure,
not just brute theism, because you need a theism that makes fine-tuning likely. And this is something I try to point out in my video, that a theism that makes fine-tuning likely requires certain assumptions about God. Maybe you think those assumptions are reasonable, like very high probability, maybe not. But I think it's at least important to be clear about what we're talking about here, because I'm not saying you've done this, but I do think some people sometimes slip into just talking about, well, how plausible is generic theism, and then making the fine-tuning argument as if it gives a very high likelihood ratio for generic theism, without talking about what assumptions are needed to make, what assumptions you may need to make to get you from generic theism to a high likelihood ratio for fine-tuning. Like, what do you have to assume about God? And we always need to be clear about what particular things we're talking, like what particular type of God or what divine psychology or whatever it is that we're talking about in any given context.
Certainly you need to have more than you need in order to conclude that theism is likely from fine-tuning. You'll need more than just saying fine-tuning is unlikely given naturalism. You'll need to do a bit more hard work. But I think that, normally if an argument like dramatically raises the probability of its conclusion, then we generally think it's a pretty good argument, even if there's a way around it. Where you could have another theory, right? So if an argument got a theory from 1% to 80%, that would be a pretty good argument. If fine-tuning...
Well, it depends if you mean by likelihood or posterior. I don't think just looking at the likelihood by itself is that informative. Posterior is yes.
Well, I don't know. I mean...
Because you can always just pack assumptions into your prior and inflate the likelihood. Like, that's just super easy to do.
Yeah, so
you can't just look at the likelihood to tell you how good a theory is.
So I guess this is semantic.
Unless there's constraints on the prior.
Yeah, I would say that if you had a theory, like suppose you have a really specific theory where your theory is theism plus God would make exactly this universe. That theory, obviously, it perfectly explains all the data, but it has ridiculously low. It has ridiculously low prior. And so with a theory like that, I would say you have really strong arguments in its favor, namely that it explains the evidence. It just has a low prior.
Okay, that's just a semantic difference. Right, I wouldn't say it that way, but okay, that's fine. That's fine. Okay, so then it seems that we agree that you're going to need to say something about the nature of an infinite being in order to make design inferences. And I think then the question is going to be perhaps exactly what we need to say, and also how plausible are these sorts of inferences. And I mean, it's probably not going to be surprising that first of all, I'm very suspicious about our ability to make any sorts of reasoned judgments about these sorts of things. We're talking about infinite beings and the different types of universes that could exist and his reasons allegedly for creating or not creating different things. Even if God existed, I'm not sure that we'd really have much ability to intuit that just by thinking about it. I'm very skeptical about that idea. But also then, that's a more methodological concern. The second point then is about what those probabilities actually look like when you try to do that analysis. And my criticism is that, I guess my meta argument is that people anthropomorphize a lot. They think about how humans would behave and imagine a really powerful human, and then make inferences based on that, whether they're acknowledging that or not. And I just don't really accept those sorts of inferences. Like, well, a human artist would want to sign their work, but does that mean God would want to sign the cosmos? What is similar about God and a human such that it's reasonable to make that inference? I don't believe those sorts of anthropomorphizations when there's so many differences between God and humans.
Yes, certainly we should not assume that God is exactly like humans. But in the signing its name case, I agree it's improbable that God would sign its name, that the initial conditions would spell it made by God.
Yeah, maybe I shouldn't have raised that example again because we sort of acknowledged
Yeah,
that
but
it wasn't
the question
best
is,
one.
is it so improbable that it's more improbable on naturalism? Or I think it's very improbable, but it's way more improbable on naturalism. And I think we can just see this by thinking about it intuitively in a similar way to how we can intuitively see that, even if we haven't yet done the math, it's way more likely that my brother would write out a note to me than that there would be a random ink spill that happens to spell out English sentences.
Well, so I want to at least see in maybe the last few minutes if we can get, if I can understand a bit better about why you think we can make that sort of inference, because I think we both agreed that random ink spills or crows on typewriters, that we have background theories about people and about all of those systems that we can appeal to make those sorts of inferences, even just intuitively. And I would say that we're not even always right in those, like when we do that. In those two examples, I agree. Like the intuitive answer is the correct one, although I think often we're led astray. But that's a separate point. We appeal to background theory and knowledge, right? Now, my concern is that we don't have similar background theory or knowledge that we can appeal to in the case of God. And so I think that what you would want to say is, well, we can appeal to what we know about, let's say, moral agents, because we're supposed to be moral agents and God is supposed to be a moral agent, right? I guess, well, maybe that's about as far as I can take it, because I'm not really sure what else one can say. In virtue of, here's the background theory that I'm appealing to make these judgments about what God would be likely to do. What would you say about this?
I mean, I don't have like a precise background theory of coming up with exact.
It doesn't have to be precise, just sort of.
Right. So
I didn't say it has to be exact, but just general observation.
What we reason is that God is an agent and he's a perfect agent. And so if there's something that whatever we reason about what the probability is that a perfect agent would do particular things, right? So maybe so take for example the if it's spelled out made by God, if the initial conditions spelled those out. In that case, you would say, okay, maybe a perfect agent would want to inform people that he existed, but only after certain after they've done some scientific discovery, right? Maybe if he informs people too early, then they'll sort of all fight over who the true God is. So really, he only wants to clinch it after they've done really developed science and reached some degree of enlightenment. I agree that won't be super probable, but whenever we infer an agent did things, we're almost never making the claim that it's super probable, and we're almost never having inferences of the form we can assign a precise probability to this. It's always very hand wavy, but we can still make judgments about certain things being more expected on the hypothesis than agent did it.
There's hand wavy and there's hand wavy, right? So I think that we have a vastly stronger basis for making inferences about humans writing books and writing notes than we do for what an infinite being would be likely to create in terms of a cosmos. So let's take your example about maybe he put the message there to inform people, but only about his existence, but only after a certain amount of scientific development or something like that, when we could detect it. What theory is that appealing to? Like, it just seems to be an ad hoc explanation to me. I'm not objecting to the fact that it's kind of vague, because there's always going to be some vagueness where we can't calculate everything, right? That's true for any or most sorts of inferences. But I'm saying it doesn't seem to be appealing to any accepted knowledge. We could just as well say, well, God wants to always leave it open, or he wants it to be obvious from the earliest point of time, or he wants it to be obvious, but he would send a different message. And I think, again, maybe it would be more helpful to talk about life, because that's more directly relevant to the fine-tuning argument, right? That there's supposed to be a sort of moral reason for God to create a universe that sustains life. One of my criticisms that I don't know what moral principles are being appealed to there that we would expect God to that we have a reasonable background for thinking about what a perfect being would create. Why do we expect that a perfect being would want to create embodied conscious life? That I don't know what background theory is being appealed to there. Humans can't even agree whether it's good for humans to create more humans, like in terms of pro versus anti-natalism. Like what that's just sort of an example that I don't know what background theory is being appealed to that would say we can make this sort of judgment.
In order to see the probability that God will create embodied conscious agents, you'll have to look at what the probability is. Right. So if anti-natalism is true, then God clearly wouldn't create embodied.
I know that's not a perfect analogy for God making new life, right? It was just a vague reference to the idea that we're not certain about really
So,
much of any of these things for humans, let alone what a god would do.
So,
So what
this is
theory is
one
being appealed
thing
to?
that I think you do a lot, which I have pretty substantial disagreements with, where what you'll do is you'll say we have no idea what the odds are, and then you'll list a bunch of options of ways that something could be different. But I think that it's true that the odds, we don't know exactly what the odds are that God would make embodied conscious agents. But embodied conscious agents, if we think sort of intuitively, if we think we have some kind of moral knowledge, embodied conscious agents are either the only thing that can be of value or are the primary thing of value in the universe. And so why would God want to make either the only thing of value or the primary thing of value? Well, because he's a good God, and good gods will care about bringing about things of value. And so that's why he would make things. He would make embodied conscious agents, even if you're skeptical of this. And I agree that there are certain bits of the universe where it's very unlikely that God would make our exact laws of physics, just as it's very unlikely conditional naturalism that you'd have our exact laws of physics. But I think the fact that there's life at all will dramatically favor the existence of God, because it's probable that a God would want to create life like that.
So if we have a theory about, be careful how I say this here. If we have a theory about, let's say, morality, which then allows us to make inferences about what a perfectly good moral relation would do, that does provide us with at least some constraints or some background theory, as I was calling it, on what a perfect moral relation would do. Now, your claim was that, well, we have one such theory, which is that embodied moral agents are one of, or maybe even the only type of valuable thing that exists. Or that I don't know if you meant to say that exists or that possibly could exist. Maybe I think that's kind of relevant here.
I would think. I think. Yeah, that's a good question. I think probably they're the only valuable thing that exists. I don't know exactly how likely it is that they'd be the only valuable thing that could exist, but they'd certainly be a valuable thing that could exist, and so God would be expected to create them. Maybe maybe there are other things that are of great value, and God creates those as well.
Well,
and some people think there are things like that, like trees, that even though
if there are but those are things that actually exist. I think more interesting is the question. Yeah, things that don't exist in our universe that have moral value. So again, that was a bit of a clarification there. The point that I want to make is I don't agree that we have that type of knowledge about what things are that are the sort of fundamental unit of value. That it's sort of let me be clear what I'm saying here. I agree that in our universe and in the way that we deploy moral language, embodied conscious life is morally valuable. Well, yeah, let's just go with that. It's okay. So that's one claim. To then say that, so I guess it follows from that embodied conscious life is a thing that's morally valuable. Okay, fair enough. To go from that to say that it's one of the few things, or even the only thing, that is possibly morally valuable, that's the leap that I'm not willing to take, because I'm imagining what a perfectly good God, perfectly good moral agent, if they had kind of all the options to create anything of value, what would it be? And I honestly have no idea. I feel like it's hubris to say, well, it's going to be things like us, right? Because we're pretty awesome. I've given some examples in other contexts. I feel like giving examples is sort of misses the point, right? Because a lot of these things I don't even expect us to be able to imagine. But there's many different theories about what is fundamentally morally valuable, and even those theories apply generally to our universe, not other hypothetical universes that God could have created. So it's again this extrapolation that I'm not really comfortable with. I think our moral concepts are suitable for the way we typically deploy them, but if we're then to ask a question like, what would a perfectly moral being with all power create so as to actualize something valuable? I don't know. I don't think anyone knows that, and so I don't agree. Let me just draw that back. And therefore, I don't agree that we have this background knowledge that we can reasonably appeal to make inferences about what God would be likely to do. And so that's where I differ from that case versus the examples of human writing notes or books. So I'm disagreeing with you when you say that you think we have this relevant background knowledge about moral nature.
3 points about that. First of all, even if you're probably right, as long as there are non-insignificant odds that humans are the only thing of value, or sorry, not that humans are the only thing of value, but that sort of embodied conscious life is the only thing of value, then you still get not terribly low probabilities of it conditional on theism. Well, I think the odds conditional on naturalism are very low. Second of all, even if there's lots of other stuff of value, maybe, if there is lots of other stuff of value, probably that other stuff exists just elsewhere in the multiverse. And third, so I mean, there's this principle of called welfarism, where the idea of welfarism is for something to be good, it has to be good for someone. Welfarism, I think, it's intuitively plausible. It sort of seems right when you think about it. Maybe we're not certain of it, but we should at least think that there are decent odds of welfarism. And if there are decent odds of welfarism, then there are decent odds that the only thing of value is embodied conscious agents, just based on the idea that if to be good, something has to be good for someone, then the only things that could be conducive to goodness are people existing, or at least they're a prerequisite for things being good.
So I feel like the second thing you said about the multiverse, and the third thing you said about welfarism, as you've characterized it there, I've heard welfarism characterized somewhat differently, but I think both of those things open big cans of worms that we don't have time to get into. I think if we start talking about, we haven't talked about multiverses so far. I think that multiverses provide an interesting other avenue for explaining many things. I think if we're going to hypothesize divine multiverses, meaning different universes that God has created that sort of don't interact with each other, then we should also consider naturalistic multiverses and what that entails.
I certainly agree, and I think that whether you're a theist or an atheist, you should think there's almost certainly a multiverse.
All right,
But I explain in an article called "There's a Multiverse" that people can check out. If you go to the link below, you'll find my blog.
Fair enough. I just wanted to acknowledge that, but let's not go down that one here. Now, the third point was about for something to be good, it has to be good for someone. That confuses me a little bit. Now, perhaps I just don't understand this well enough, which I'm open to. But my understanding was that people who make that argument typically say that bringing someone into existence is not good for that person, because for something to be good, it has to be good for that person. And it's not, it doesn't make sense to say bringing them into existence is good for them, because it's relative to like what.
Okay,
so under that view, it wouldn't even be true that God creating life would be a good thing. At least that's how I've understood it.
Suppose that you dropped someone, you brought someone into existence over a furnace where they fell into the furnace and burned to death. Would that be bad for them?
No, I'm not. I don't want to get into the argument. I'm just saying that my understanding of that particular viewpoint is that you can't actually say whether it's good to bring someone into existence or not. Only what happens while they're in existence. And so that particular position wouldn't, I think, support the position that you're advocating.
No, I don't think that's true, because I think that just as it's bad for a person if you bring them into existence and they have a really miserable life, if it's bad to bring someone into existence above an open flame so that they burn to death. Similarly, it's good for someone to be brought into existence and live a good life if the alternative is non-existence.
But the only reason there are many people who disagree with that, and that includes people who advocate for the principle you were just advocating as evidence for the moral principle that we can appeal to.
Right, I agree.
So that's all I wanted to say. I don't want to say whether I agree with it or not, or debate.
Well, yeah, I agree. There are people who disagree with that, but I think that those people are clearly wrong.
So you can't advocate that as like a widely accepted moral principle that supports your position, because it isn't.
Well, I think so. I wasn't claiming that the principle was anything like certain, but I think it's a sufficiently plausible principle that you should think that it's decently likely.
But people who accept I'm not saying how likelihood. All I'm saying is, from what I've understood, many people who accept that for something to be good, it has to be good for someone, or likewise bad, don't accept that bringing someone into existence is good or can be good or bad for that person.
Right.
And therefore, that principle won't support, understood that way, it won't support your argument. That's all I was saying.
So I think those people are wrong. But even if they're right,
that's fine. That's fine.
And just to be clear, even if they're right that bringing a person into existence isn't good for them, then I think that the theory will have to be suitably modified to say that that there are things that are good other than bringing them in. There are things that are good other than making existing people better off, because I think it's very clear, and you can give lots of arguments for the conclusion that it's good to create a happy person.
Yeah, that's okay. I was just, yeah. I'm not saying you can't give further arguments. I was just talking about that principle itself. So I think now might be a good time to wrap up. So I would just like to summarize kind of some of the things that I've said and try to clarify my position. And I'm happy to let you have the last word to summarize after I've. Is that okay?
Yeah.
Yeah, I'll summarize for a bit, and you can then summarize yours and finish up. So yeah, so we talked about a lot of difficult ideas today, and yeah, these are still things that I'm thinking through as well. So I don't want to say that I, have come to the sort of final enlightened view about everything. I want to thank Matthew for having me here. I think it was interesting, and I enjoyed the conversation. I want to apologize. I know sometimes I can come across a bit strong. It's just because I really value reason and taking things seriously, and don't get frustrated sometimes when I think people are a bit too ready to make kind of unjustified inferences, and maybe that's a character flaw on my part. But anyway, so I apologize for that, and I do appreciate being here today. Let me just briefly summarize some of the things that I've argued for. So the first part of what we talked about was about the idea of different laws of different possible laws of fundamental physics, right? And we talked about the idea of the simplicity of those laws versus the what we call the predictivity. So like how much you could predict within a universe governed by those laws, what would happen, like induction and things like that. And I made a few arguments. One argument that I made is I think this notion of simplicity is a bit slippery, particularly when applied to different possible universes and laws of physics. I think we can apply the principle in some contexts. That doesn't mean it's applicable in every context. So that was one concern. Another concern I had was I don't think there's necessarily a very strong relationship between the simplicity of the laws and the predictability. And this was relevant to something Matthew argued about the idea that we need to sort of balance between the laws of physics being complex enough to give rise to life, but not so complex that things will become unpredictable. I'm not sure that sort of relationship between simplicity and predictability is really that robust. So we talked about that. That's another thing that is the basis of my concerns. And then we talked a bit about Conway's game of life and the sort of conceptual basis of the idea that it's sort of hard to make complex, interesting behavior emerge in any given system. And so most systems won't have these sort of complex behaviors analogous to life. My concern there, and we agreed in saying that Conway's game of life is an interesting sort of thought experiment. Well, it's not even a thought experiment. Like it's an interesting case study to think about these sorts of things. My concern was in extrapolating from fairly simple system to very complicated systems like our actual laws of physics or like similar possible laws of physics, and saying that when there's a much higher level of complexity, that there's still a relative that it's still relatively unlikely that you're going to see complex behaviors. I'm much less willing to make that sort of inference and think we know much less about what would be possible in universes with different laws of physics. And we also talked a bit about things like the cosmological constant and whether we can reliably know what would be possible in terms of the existence of life in universes with different constants. And my general position is of sort of skepticism about our ability to know those sorts of things, given that it involves a lot of extrapolation. And then the final point we talked about was with reference to making a design inference. So we talked quite a bit about when we can infer design and agency. And we both agreed that there are cases where we can do that. Even if the probability is not high, it's still potentially better than alternative explanations. There are at least some cases where we can infer design, but there was some disagreement about exactly how we make that inference, and particularly my argument is that when we infer design, we need to appeal to background knowledge about the agent or types of agents in question. And the concern is that in the case of God, my concern, I should say, was whether we don't have that kind of background knowledge that we can appeal to in making predictions about what God would likely do or likely want. And in particular, we closed up by talking about the issue of God as a moral agent. So just the fact that God is supposed to be morally perfect, give us, or can we use theories about morality or about what a moral agent would do to make as a basis of a background theory to then make predictions about what God would likely do great. And I expressed skepticism that we have any sort of sufficient such theory to make robust inferences there. And raised concerns, and Matthew raised the concern that I'm perhaps too willing to do this, to say, well, there's many other possibilities that we don't know about. But so my view is that should raise a lot of concerns about whether we have any real theory about what a perfect moral agent would be likely to do. So my argument, therefore, is that when you absent such a theory, you can't really say much of anything about what a perfect being would do or what a divine agent would do. And in fact, there's a vast array of possibilities of what God could do or would potentially do that exceeds what's even possible under naturalism. And so if you use the same type of approach to characterize the odds of a state of affairs in one versus the other, then you actually get a similar issue of theism not providing very high probabilities of any particular outcome. And my concern is we don't have the requisite background theories to be able to remove that issue. So I think if I were to summarize the most basic disagreement here, and you can feel free to characterize this differently if you would like to, this is just my characterization of it, is that when it comes to making these sorts of inferences about, say, simplicity of laws or how likely it is life could exist in certain laws, or about what an infinite moral agent would do, or these sorts of things, I'm just much less willing to make these sorts of inferences, and much more skeptical about that sort of extension of our judgment, which in my view is a very large extrapolation. And I think that you can kind of see that throughout the conversation that I would be sort of pretty skeptical on those points. So that's my summary of what we've talked about, and I think a fair characterization of what I've sort of argued. So yeah, that's it for me. Thanks again, Matthew, and I'll pass to you and let you summarize your view and close this out if you like.
Yeah. So thanks so much for coming on, James. And our chats are always interesting. You always sort of raise thought-provoking points. So I mean, I don't think our conversation was that heated, but sorry, to the extent,
that's fine.
To the extent it was. Yeah. So I guess I think that I have a few disagreements. One of them is, you say you're worried about this notion of simplicity. You think it's a sort of slippery concept, and you're worried about leaning too much into the idea of simplicity. I think, for the reason that I described, that you're going to need to have some measure of simplicity in terms of the fundamental laws in order to hold that the laws are going to be predictable, and in order to trust that induction will hold into the future. So for that reason, I think we're going to need to do some analysis in terms of simplicity. And I don't think I'm relying on anything very complex. I don't think I'm relying on any unreasonable leaps about what preferring simpler theories would entail. Just that you're either going to want to have a pretty strong bias in favor of simpler theories, or you won't trust induction. And so we need a very strong bias in favor of simpler theories. And it's very unlikely that we didn't get one of the super simple theories that doesn't produce anything interesting, or one of the more dramatically more complicated theories that produces, that undermines induction. I think in terms of the conceptual fine-tuning point, where just the majority of possible laws don't produce anything interesting, I think we can see this in lots of areas where, just write a random computer program to have stuff moving around according to simple laws. Almost certainly it won't produce anything interesting, complex, or valuable. John Conway had to work really hard for his game of life to produce anything interesting. Or the laws of physics are such that if you delete any of the laws, you wouldn't produce anything interesting. So I think the lesson from this is that complexity and value is rare, and so it's very unlikely that you'd get it if you don't have an agent that's working to bring it about. James is very skeptical of a lot of these instances of divine psychology. I agree we can read too much into divine psychology, and it's hard to know what God would do. But I don't think the alternative is to just say, well, it's all sort of hand wavy and to throw up our hands, because I think there are lots of cases where, of course, it makes sense to infer that things are better explained on the hypothesis that there's a God. If we observed that the initial conditions spelled out made by God, even though psychologizing why God might do that is a bit hand-wavy, it would still be a much better explanation than that was just brute and there was no deeper explanation of that. In terms of the point about it being hand-wavy, I mean, we talked about this a bit, but I think pretty much any time you use an agent to invoke things, to explain things, it's very hard to assign probabilities. You can't do it in any precise way, but we can still be confident when certain events happen. If you see a painting, you should think it wasn't just a series of ink spills that resulted in it. It was instead almost certainly the case that an agent made it. In a similar way, when you observe that, if you observe that there's life, which is both very valuable and very improbable, if the arguments work, then you should think that provides strong evidence for the existence of God. In terms, the last thing, we talked a little bit about what God's reasons would be to create and whether we could know it. I think we can be pretty confident that God would create conscious agents, because I think conscious agents are of great value. Maybe they're not the only thing of value, but if there's other stuff of value, maybe God made that too. It's at least not terribly unlikely. So the fact that it is terribly unlikely on atheism gives a strong point in favor of theism. So yeah, I guess those are sort of my 2 cents. Thanks for coming on, James. If people want to read more about my views on the topic, I have an article linked below where I talk about it. James has a blog, right?
Yes. If you just search for my name and blog, you should find it.
Yeah, and he made a recent YouTube video where you can sort of hear more about his views. So maybe watch that. But yeah, thanks so much for coming on, James. Thanks for watching,
No worries.
everyone.
Thanks very much. Take care, everyone.
All right. I'll end the stream now.
See ya.